I guess I gotta. Oh, it's on. It's on. All right. Why is that start mirroring right there? That's annoying. There we go. Okay. So let's go through the review. I'll answer any questions that you may have, and then we get to go. Sound good? Yes.
I have a copy.
Of course. I think there's an extra copy right there.
Oh, great.
Make sure that I didn't write on that.
That's a question
Yeah.
I have.
You did not.
Okay. Gotcha.
Actually, just
What are the
quiz.
Is it there? Hey.
Here's my pass, but I need to keep it.
Gotcha.
I was talking to Mr. Crossbody.
Mr. Hooper.
Wait, so we don't gotta turn it in,
Poop
right?
dog.
Just making sure.
Right, correct. Yeah, this is not like a homework assignment or anything. It's just
What was the question?
suggested problems. All right, let's get to it. Let's go question by question. With the data from the chart below, find the relative and cumulative frequencies for each class. Average high temperatures for the month of January. 9, 10. Didn't even make it the right days. Okay, so remember, relative frequency is like percentage frequency, and cumulative frequency is adding them together, right? So relative frequency, I have to find my n value right off the bat. So let's calculate that. This is 5 plus 3 is 8, 11, 14, 16. Do you guys get n as 17?
Yes.
Good. All right, so now relative frequency would be 5/17. 5/17. Now, I am totally fine with, is it a percentage or a decimal? Does not matter. 0.29. If you want to go out to the hundreds, more power to you. 3/17 is 0.18. If you round it to the nearest tenth, 0.18. 0.18 here as well. 0.18 here as well. And then 2/17. 0.12. Really? Really? Oh, it's just a cast iron.
Ooh, Mr. Steve.
Domino's Pizza. Yes, sir. I'm trying to teach class, man. No, I just spent the first 15 minutes of class going through the weather. I can't. I do. Maybe at the end of the period, I'll call you. But
Let's take a trip down this one.
That would be fun.
I agree.
1/17 is
06.
0.06.
0.059.
0.059, if you will. Yeah. Again, percentages would be fine as well. Cumulative frequency. Remember, cumulative frequency is adding up. The first class will have the same frequency, and then they start to add. So 8, 11, 14, 16, 17. First class is going to have its own frequency. Last class is going to be the frequency of that. Questions about that?
No questions.
Bueno. Now, the weird part about using a frequency polygon is that finding the class of the whatever it's asking you, right? Finding the class. Because what are these here? These are the what? Yeah, but they're the what? They're the midpoints, right? The midpoints of the class, right? The midpoints of the class. So we have to kind of think about what are the classes then? Well, if I go 60 to 69, your first instinct is probably saying, well, it's probably, if it's 3 units apart, 67.5, right? Here's the bad part about that, is if I call this class the upper limit 67.5, what is the lower limit of the next class?
4? Doesn't make sense.
Right, so you can't do that, right? There can't be any overlap, because if I had a 67.5, where would it go, right? 67.5 is the boundary, but it's not the upper limit of the class. So to take that into account, we could do one of a couple things. I could say, okay, well then 67.4. 67.4, then the boundary is 67.5, and then the lower limit of the next class would be 67.6. Easier way to do that, just make it a whole number. And just say, okay, well then the class is going to be up to 67. Right? That upper limit of the class is going to be 67, and then it will jump to 68 for the next lower limit of the next class. Right? So my first class is going to be 65 to 67. Oops, forgot my 5. 65 to 67. The next class is going to be 68 to 70. The next class is going to be 71 to 73, and then so on. So you just kind of got to reason it through. I'll accept multiple answers there as long as it makes sense, as long as it's reasonable. There can't be any overlap in classes. You can't have the upper limit of the first class be the same as the lower limit of the next class. All right, approximately how many basketball players were studied here? We've got 0 here as my frequency. Looks like 6 is my frequency. 10. We got 22 here. This looks like it's 24. This looks like 16. That's probably 20. That's 2. And then 0. So what is it asking for here? It's asking for cumulative frequency, right? So I have 6 plus 10 plus 22 plus 24 plus 16. Just don't forget about any points in there. Plus 20 plus 2. 6, 10, 22, 24, 16, 20, and then 2. So total, 100. 100 basketball players were studied. Which class has the largest frequency? Give the upper and lower class limits. So the highest frequency looks like it's the 77 to 80. Oh, no, sorry. 79. 77 to 79 class. Which class has a cumulative frequency of about 16? Cumulative frequency of about 16 here. No. See, that's not cumulative frequency. That's just the frequency. Yeah. That's the weird part about this one. This is actually 71 to 73.
Oh, I got that.
Does that make sense? You looked at actual frequency. I wanted cumulative frequency. The cumulative frequency of the 71 to 73 class is 16. Questions on 2? All right, taking a look at number 3. Your grades in English along with the weights are as follows. Find your final score in the course. Let's check to see if the weights add up to 100. I bet they do. 12 plus 18 plus 20 plus 15 plus 35. 100. Okay, cool. That means in the end, because remember the rule for weighted mean is sum of the XW divided by sum of the W, right? Sum of the frequency times the weight, or sum of the score times the weight divided by sum of the weights. But in this case, the sum of the weights is going to be 100 or 1 if used as a decimal rather than a percent. So we're going to take 72 times, no, not minus, times 0.12. And I'm going to add all these together. Plus 75 times 0.18 plus 80 times 0.2. Oh, I hit enter. Shoot. Plus 65 times 0.15. Man, we sucked at essays, didn't we? Plus 70 times 0.35. Good thing we didn't do so hot on the exam either. 72.39. Make sense? That's a weighted mean. Weighted mean. Okay, mean of a frequency distribution. That's basically the same thing as a weighted mean. The formula here is sum of the XFs divided by N. Right? That's our formula, right? Sum of the XFs divided by N. Please. Yeah. It is.
Yeah, it is.
Thanks, Bob. Sum of the XFs divided by N. Okay, so what I want to do now is find, what am I going to multiply the frequency by? The midpoint, right. So midpoint here, 20 to 23. I've got to take the midpoint from 20 to 23, which gets us 21 and a half. I'll put it over here. Midpoints. I'm going to make another column over here. Okay, so we've got, what did I say, 21 and a half. And now, instead of running that calculation each time, how much am I adding from class to class? 4. So that means 25 and a half, 29 and a half, 33 and a half, 37 and a half, and 41 and a half. Just spot check that at the end. Make sure you got the right number there. Oops, sorry. 40 and not times. Get out of there. 40 and 43 divided by 2 gets us 41 and a half. Perfect. All right, so I take my x times my frequency, and x in this case is our midpoint. So 5 times 21 and a half plus, not plus, sorry, I do want to add them, but I want to write them out. 107.5. And then we've got 25 and a half times 3, 76.5. And then we got 3 times 29 and a half. Again, statistics is a lot about staying consistent, not messing up. 3 times 33 and a half, which I tend to do when I try to talk and do math at the same time. 2 times 37 and a half, which gets me 75. And the last one here, 1 times 41 and a half, which is 41 and a half. All right. Now, the formula is sum of the xf's. So I sum all of that together. 107.5, 76.5, 88.5, 100.5, 75, and 41.5. Let's make sure I type that in all right. 107.5, 76.5, 88.5, 100.5, 75, 41.5. All right, sum of the xf's is 489.5. All divided by our n. And remember, n is our total frequency, right? So 5 plus 3 plus 3 plus 3 plus 2 plus 1, right? So what was our n? Oh, that's right, the same one. 17, right? Divide that by 17. So our average temperature, based on those frequencies, was 28.8. Questions about that? Okay, let's take a look on the second page on the back. Consider the following data set. Calculate the mean, median, mode of the data set. Which choice would you likely give as your best measure of central tendency? All right, so I had an A. Did I really have an A right there?
Yeah.
Yep.
That A should not be
Is
there.
that the outlier?
Yeah, really. Is that the weird one? That's really funny. 8 plus 8 plus 8, so 3 eighths, 10, 10, 12, 14, 15, 17, 35. Okay, I'm just going to double check. 8, 8, 8, 10, 10, 12, 14, 15, 17, 35. Okay, and what am I going to divide that by? 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Sweet. 13.7. So X bar is 13.7. I guess, or mu. We don't really know whether this is a population or a sample. X bar or mu, whatever. 13.7 is the mean. Let's take a look at the median. Median. All right, so median is going to be what's the median? 11, right? When it's a data set that you have two numbers in the middle, you just find the average of those two. So the median is 11. And what was the mode? Mode was 8, most common number. All right, so which would be the best measure of central tendency? The median. Why? There's a better reason for that.
It's not affected by
It's not affected by the outlier. right? It's not as affected by the outlier. And I wouldn't use a mode in this case because the 8 is our smallest value, and it doesn't represent the middle of this data set. All right, let's make a stem and leaf plot and then a dot plot, shall we? Mm-hmm. All right, stem and leaf plot. 4, looks like 4, 5, and 6. Okay, is this all in order? Sweet. How nice of you. 1, 2, 2, 3, 4, 8. 1, 1, 2, 8, 9. 0, 1, 2, 2, 3. Good. Make sure you add a key to it and say for line 1 means 41. Make sure you add a key to it. Yeah, I would say, because then you don't know, like if you had that same data set, 4.1 could mean 4.1. 4.1 could mean 4.1 million. You know. And then a dot plot. Let's go here, 40. Let's go in the middle, 50 and 60. And I'm going to erase away that little dot. Okay. And put a 45 right there, 55. Oh, I need to go above. Shoot. 70, 65. All right. I'll change colors for emphasis. So 41, 2 42s, 43, 44, 48, somewhere right there. 51, 51, 52, 58, 59, 60, 61, 62, 62, 63. Good? Pretty simple then. Let's do a pie chart. A car dealership wants a pie graph of amount of cars sold in each quarter. In quarter 1, 450 cars were sold. In quarter 2, 600. I should make a table while I'm saying this. In quarter 1, we had 450 cars were sold. In quarter 2, we had 685. In quarter 3, we had 267. And in quarter 4, we had 900. We were on fire. 975 cars were sold. Construct a pie chart. Okay, so what I'm going to do here, I am going to show the percentage. I'm going to show the relative frequency. And then I'm going to show the actual degrees that I need to use. All right, so total amount here looks like I've got 450 plus 685 plus 267 plus 975. Okay, 450, 685, 267, 975. 2,377. N equals 2,377. That's how many cars we sold in the year. All right, so let's find the relative frequency. 450 out of 2377 gets us 0.189. I'll go a little bit more. I'll go 18.9%. Just being fancy with it now. 685 divided by 2377 gets me 28.8%. 267, relatively low. 267 divided by 2377. So in quarter 3, 11.2%. And 975 divided by 2377 gets us 41%. 41.1. Just 41. 41.0%. All right, let's find the degrees for each one of these. Okay, So we say 0.189 times 360, and that gets us 68 degrees. And again, you can round to the nearest degree for this. 0.288 times 360 gets us 104. 104 degrees. 0.112 times 360 gets us 40. Oh, not percent, degrees. And then our last one, the big guy here, 0.41 times 360, 148 degrees. Okay, let's make our pie chart now. Let's go with our biggest chunk. In Q4, we had 148 degrees. So here's 90 degrees, 180 degrees is down here. So 30 past would be 120, 150 here, so something like that. This is going to be Q4 with 41% of sales.
Are you gonna want us to write the degrees, or is it fine if we just like use the percentages?
Show the degrees. Yeah, show the degrees.
Show the work.
What I mean when I say show all work is show the percentage and show the degrees.
Okay.
Yeah. We got 40 degrees. Let's go off this one. So here's 90. So 40 degrees, a little less than halfway. Okay, so there is Q3 with 40 degrees. Oh, no, sorry. 11.2%. Let's do 104 degrees. So if that's my 90, a little bit more than 90 here would look like something like that. There is Q2. And this must be Q1. And we'll put in our percentages here. Q1 was 18.9%. And then Q2 was 104 degrees, so 28.8%. Questions about that?
No.
All right, let's finish this off and draw a skewed left, skewed right, and symmetric. Easiest one, let's draw the symmetric. Symmetric graph looks bell-shaped, right? Where the mean, median, and mode. Mean, I put a D first. Median and mode all line up exactly on the same. Okay. So now let's talk about the right and left. All right. Okay, now remember, the direction of the skew is where it was pulled, right? Where the outliers are pulling it. Also, where is the tail? The tail is long on the left side. That's a skew left. It's pulled left, not where the bump is, but where it was pulled. So therefore, skewed right means the tail is on the right side. Something like that. And not only be able to tell visually what it is, but also correctly place the mean, median, and mode. Remember, mode is always at the top. The most frequent thing. Right? Now, the mean and median, you got to think about logically. The mean gets pulled by the outlier. So if there are more outliers over here, well, the mean is going to end up here, where the median is going to be in the middle. Same thing over here. The mean is getting pulled by the outliers, so mean would be more over here, where median would be in the middle of those two. Should put those lines in. You get the idea. So how do we feel on tomorrow's quiz?
Still be worthy, but good. Key.
You gonna make me a key?
No, sure.
Just so you can do it on the calc, please?
Yep. You don't want to see my calc quiz.
All All right. Are there any questions? Anything else for the good of the order?
No.
Statistics.
With 20 minutes to spare, people. With 20 minutes to spare. All right.
Goodbye.